So the property of the tangent function essentially then is it's going to repeat itself every pi radians. Okay, so it's got a period of pi, so it only needs to go through half a circle to go through the full length of the y values along that tangent line. So it repeats every pi. You could think of it as it has a period of 2 pi and it goes through the y values twice, because if you want to think of going through quadrant 3 and 2 and 3 as completing the full circle, then you could think of it as going through a full circle and it goes through those two periods twice. The important parts are the references, and there's going to be the asymptotes. So you're going to have asymptotes at pi over 2, 3 pi over 2. Every pi radians where we're going to have a vertical asymptote, you're going to have, where you're going to hit the vertical asymptotes, you have an undefined value. Okay, so every pi radians. And we should make note here, and I didn't actually put it on here, but we should make note we had zeros. Zeros are at x equals 0, and then the next one is at pi, 2 pi, dot, 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 dot. Okay, so those are where our zeros are going to be. And again, we can still continue to look at tan as sine over cos. Again, if we look at that, where the ratio of this side to this side is equivalent to the ratio of sine to cos. Okay, so then we can still use that y over x ratio to describe the tan function. Okay, so let's do some graphs. So let's take a look at the graph here. So we have a period of pi from negative pi over 2 to positive pi over 2. We have our asymptotes. And again, our zeros are going to occur. We're going to start at 0. We're going to have another 0 at pi in the next period. Okay, there'll be another asymptote here. And if we go to negative pi, okay, every pi, we're going to have a repetition of this graph. Now there is a reference position that we may or may not use, but you should be aware of. And this one here, at 45 degrees or pi over 2, there is 1. And at negative pi over 2, sorry, pi over 4, we're going to have a y position of negative 1. Okay, so those, we may use those as reference points, but for now we're going to just focus on the reference being the middle and the asymptotes. These reference points are actually very useful to show vertical expansions, but at this point we're not going to focus too much on that, and we'll maybe get to that at a later time. So let's draw a graph of tan. So there are some important things that we need to know. We need to know the center. Okay, we need to know where the center is. We need to know where the period, we'll call t, okay, which is our period. Okay, we need to know what that's equal to. In this case, there are some vertical shifts and horizontal shifts that allow us to locate the center. So when we locate the center, we're going to make sure that we know the two different parts that make up the center, the vertical shift, the horizontal shift, and vertical shift. Okay, and in this case, we're not going to call an amplitude, but we're going to call it is related to the amplitude, and it's a vertical expansion factor. And we may, at this point, we're not going to worry about graphing that vertical expansion, but we should be aware of exactly what it is. So if I want to find the center, I'm going to look at this, and it's been transformed. It's been horizontally shifted to the right, pi over 4. Okay, and it's been vertically shifted up plus 1. So the center coordinate is going to be at pi over 4 plus 1. Okay, so that's the nice thing about this graphing formula that we have. We can locate the center by just looking at that graph. The period of this function, okay, there is no horizontal compression or expansion, so the period is going to be pi, and the vertical expansion is going to be by 3. And we should also maybe indicate that there is a vertical flip involved because of that minus on the 3. Okay, so how are we going to graph this then? So I need to make sure that I can accommodate my horizontal shift and my period of pi. So I'm going to maybe draw my axes, my y-axis here, and I'm going to say that my horizontal shift of pi over 4 is maybe right about here. That makes pi over 2 here, and then 3 pi over 4 here. So first going to locate the center, okay, and I'm going to make negative pi over 4 over here. So I'm going to do a little bit of scaling here on my x-axis. My y-axis, I know that my center is going to be at +1, so I'm going to maybe make that equal to +1. So there's the center coordinate. So maybe I'll just highlight that in yellow. There's my center coordinate. I want to use my period to be able to get the asymptotes. Okay, so my period is pi. So my reference for my asymptotes, I need to go, half of that period goes to the right of the center, half of it goes to the left. So I'm going to go pi over 2 to the right. Okay, so 1/4 pi plus 1/2 pi is going to give me 3/4 pi. So there's my asymptote to the right. 1/4 minus 1/2 gives me -1/4. So that's my asymptote to the left. Okay, so I took half the period to the right. So there's my period of pi. Half of that, pi over 2 to the right, pi over 2 to the left. Okay, so again, I'll just highlight that in blue just to let you know that those positions were identified by using the period. So at this point here, I just really have a good sense of the graph because I know my graph's going to kind of look like this. I'll just kind of sketch it in. Okay, now I haven't accommodated the vertical expansion, which I'm not going to deal with right now, but I do have to accommodate a vertical flip. So instead of looking like that, I know that it got flipped in this direction. And since I have my references, my center, my asymptotes, I can just now sketch it in. So I'm just going to take my pen here and just follow the asymptote, go through the center, follow the asymptote, and that's it. So my references right now for this point, at this point, is only going to be the center and my asymptotes. Okay. Now later on, we may show that vertical expansion, and we would have to use these reference points, the 45-degree reference points, to show the vertical expansion. We might do that later, but for now we're just going to avoid doing that to simplify things. Okay, so same thing here. We want to graph this function. Okay, I want to identify the center of this graph. Okay, so where is the center? The center is going to be based on the horizontal shift and the vertical shift. So the horizontal shift is left pi over 3. So I'm going to go negative pi over 3 as my center coordinate. And it went down 1. So there's my center. The period of this function, there's no horizontal compression, so the period's still going to be pi. That means that from the center I'm going to go half pi to the right, half pi to the left. Okay, and so I'm going to use those two positions, and I should maybe identify my vertical expansion factor is times 2. It did not get flipped. And again, we need to make sure we identify that, but for now we're not going to worry about graphing that. All right, so then I'm going to draw my axes in here. There's my y-axis. And I need to do a horizontal shift left pi over 3. I'm going to put pi over 3 right about there. Now this is where it gets a little bit trickier in that now I have to accommodate half pi to the right, half pi to the left. Oops, sorry, I should draw in my vertical shift too. There it is, -1. Okay, so now I have to accommodate my asymptotes, half pi to the right, half pi to the left. So I need to do some fraction addition, subtraction. So -1/3 plus 1/2, it's going to end up at 1/6, positive 1/6. Okay, so that's -2/6 plus 3/6 gives me 1/6, positive 1/6. -2/6 minus 1/2, which is 3/6. So 2 minus 3, -2 minus 3 is -5. So I'm going to end up at, right about there, is going to be about -5/6. Okay, so I'm not, as long as your scaling is not too bad,